As the environment is becoming increasingly threatened, it's important to understand what role humans play in that degradation and what we can do to prevent it. So to contribute to that understanding, my summer research focused on tadpoles and their responses to human-induced environmental stressors. The first of those stressors are pesticides, which run off from agricultural sites into wetlands. And the second is salinity, which, because of climate change, has been found in increasing concentration in wetlands. Previous research has shown that individually, both pesticides and salinity have decreased growth, activity, and survival. So the goal of my research was to assess the responses of the southern toads to these stressors, as well as look at the combination of pesticides and salinity to see if they had a multiplicative effect rather than a simple additive effect. So I began by heading out to Francis Marion National Forest to collect tadpoles, and brought them back to the lab where I conducted my experiment. I used 320 of them, each in a glass jar with a liter of their treatment water. As my poster indicates, there are 8 different treatments in which I use combinations of fresh and brackish water with 3 different pesticides. These 3 pesticides, atrazine, carbaryl, and glyphosate, are among the 3 most popular in the United States, and the amount of pesticide that I used is considered environmentally relevant, meaning that these concentrations can in fact be found in wetlands in the United States. Then after 10 and 20 days, I went through a series of observations and data collection. One form of data collection was an activity observation, in which I observed each tadpole 20 times, marking them as either active or inactive. Another observation was testing their burst speed, where I set up a video camera to observe the tadpole's swim response to a stimulus. I did this by poking a tadpole with a glass rod at the base of its tail. I also weighed the tadpoles at 10 days and at metamorphosis, and I recorded the number of days it took to metamorphose. This allows me to see how the treatments affected their size and growth rates. Apart from the academic experience, I also benefited a lot personally from this. I think most importantly was the sense of independence in the lab that I gained. I think it was just a few weeks into my project, I definitely felt a transition from having to consult Dr. Welch every step of the way to actually being able to assess the problem on my own and just think critically about what needs to be done and do it without asking any questions. And that was a big step for me, just to take that responsibility into my own hands. My summer research also gave me a better idea of what actually goes into a research project and the magnitude of it all. Beginning with a proposal and then moving on to actually conducting the experiment and working through some of the complications. And then once you've completed that, you still have all the data you've collected, and it's quite a task even just to figure out what was important, what was significant, and what you really want to communicate. And I have yet to even finish the entire research experience because I'm going to continue on in the spring with more analyzing of data and hopefully writing a paper. So I'm certainly not done, and this has only opened the door to a wide field of academic research for me. Overall, the project was just extremely rewarding, specifically when working with an animal like a tadpole. You get to watch it grow from its tadpole phase to an actual metamorphosable toad, and that growth seems almost symbolic of the project because you get to culminate by releasing this new animal into the wild, and it's really exciting. It's critical to advance our understanding of human degradation of the environment, and I think that this experiment can do a good job accomplishing that, so I'm very excited to see where it takes me.